So this is the Pearson Edexcel Pure Maths paper from Regular Maths A-Level from October 2021. I'll just say before we start this, apologies in advance. I find Maths A-Level in its current state quite frustrating, which a lot of people who know me already know. And by extension, I find doing A-Level papers quite frustrating. And that's going to show up in this video. So apologies if I let that get the better of me. I didn't really want to do any of these papers, but enough people have asked now that I sort of feel like I'm probably strong enough to do at least a couple of them and then just leave it there. But yeah, apologies if this doesn't. Yeah, cool. Okay, so this is just a factor theorem question. So we just write down factor theorem. If x minus a is a factor, then f of a is equal to 0. So we just replace a with 1 here, and we get that f of 1 must be 0 if this is true, which it apparently is. So just put 1 into here and set it to 0. The ones don't really even do anything, and we just solve this and we get a is 3. Good, so some 3 marks there for just knowing what factor theorem is. We get 4 marks here for just knowing GCSE maths. We halve this number to make a 2, then we always take away that number squared. So always take away 4 here, in this case 2 squared is 4, tidy that up, and then here meets the y-axis at p. Well, it always meets the y-axis at this number if you're in standard form here, so it's just 0, 5. And then the minimum point is negative this number, so just 2, 1 in this case. And yeah, nice and straightforward. This question's a bit more interesting. If the first one is 2, then the second one is k minus 24 over 2, which is k minus 12. You can get the third one by putting k minus 12 into here. A bit more work to do now. Times this by k minus 12 over k minus 12, and then you've got the same denominator, so you can just take away the 24 in there as well. And yeah, that's that. And then it says this thing here is true. So we take this, we add 2 lots of that, and then we add that, and we apparently get 0. I think I put these together first. Then I times everything by this denominator, because 0 times this is still 0. And we got this, expand this out and tidy it up, and you get what they asked for. Find the value of k. Well, you've got a calculator for this paper. So you just type this quadratic into your calculating solving function thing, and calc says this. Then you remember when you went to primary school, you learnt to read, and it says this, so you cross out this, and the answer is 6. Find the value of u3, you just put 6 into there, and you get some relatively easy marks. Just note that you didn't have to do the most difficult part of that question to get half of the marks. Like 3 out of these 6 marks here was for knowing how to use your calculator to solve a quadratic, learning to read, and then substituting a number. That got you half the marks in that question. Good. Question number 4 is, I think, really just testing whether you know how to differentiate log of a function of x. This just means that f dashed evaluated at alpha is 0, but to find f dashed, this obviously is just 2x. Log of a function of x derives to the derivative of that function over the function itself. So the derivative of this is 4x minus 4. So the derivative of log of this is 4x minus 4 over 2x squared minus 4x plus 5. And we set this to be 0, of course, to look for turning points or stationary points. Times everything by this denominator, because 0 times this denominator is still 0. Tidy this all up, and we eventually end up with the quadratic that they want us to, which shows, and so because they told us that alpha was the solution, then that means that alpha is the solution to this, or at least one of them. The iterative formula is this, so they've just rearranged this equation for this x term, I think, here. This is just GCSE iteration solving, I think. So there are probably easier ways to do this with modern calculators, but I don't really know how modern calculators work very well. So I would just type in 0.3 equals to make that the answer, and then just type in this, which is in here, and you get some number out, and that's going to be the value of x2. And then you press equals again. You get a value you don't care about because it's not asking for x3, so press equals again after that, and you get this. And then it says, and that's 3 marks, and then it says, using a suitable interval and a function, show this thing here. This is, you really just have to be told how to do this type of question, I think. You let g of x be this function here. You can call this function whatever you want. And then you evaluate it at something just below this, 3.405 would be the best thing to get it to 3 decimal places. It's like an error interval, isn't it, from GCSE. Evaluate it there, you get a negative. Evaluate it on the error interval above, and you get a positive. And so therefore, if you say these things, that there's a change of sign, it's gone from negative to positive, that the function is continuous, and this function is continuous, I should say, g of x. You could call it f dash, because that's what f dashed is kind of here. And then alpha is this thing here, because that's in the middle of the error interval that you chose. What this is essentially saying is this is an idea like this. You've got one point that's below the axis, one point that's above, that's negative and positive. The graph must pass through the x-axis to get from one to the other, because the graph is continuous. Like, it doesn't do like a tan graph and goes off to infinity, then comes back down again. It's continuous, so it must go through the axis there. That's kind of all that's saying. Question number 5 is just the worst question ever written. And I want to be clear that I'm not mad at Edexcel or Pearson for this. I'm mad at the morons in the Department of Education for putting this on them. It says solutions relying on tally and calculator technology and accessible. Well, like, you wouldn't have to print this and you wouldn't have to do this if you just didn't make both pure papers calculator allowed. Just make one of the papers non-calc, and then you can ask all the interesting questions you want and force people to do it non-calc. Like, don't. And this doesn't even make any sense, because, okay, so the obvious way of doing this, I wrote down this first, but it's not really very necessary. The obvious way to do this is just do GCSE stuff. 20,000 times an increase of this is 1.08 to the power 2 to get from year 1 to year 3. Do that twice, 1 to 2 to 3. If you just type that into a calculator, you get this. Now, that is entirely relying on a calculator, because I couldn't be able to do this by hand, but that's the mark. You just need to write down that this is the thing that you do. It's this bit where the question just takes a really weird turn. The obvious way of doing this is just to have that in the calculator and then type ands times 1.08 and then press equals a whole host of times and count how many times you press equals until the button gets bigger than that. And it turns out you'll press it 16 times, which means you're in year 17, because like the first time you press it, you get to year 2. Now, that obviously is relying entirely on a calculator, but it's full marks as long as you write down the things that they want you to write down here. Like, as long as you wrote down this line here, this last thing that you would have been doing, and getting there, these last 2 results, that would be full marks, even though it's obviously using a calculator. But what's even worse is the way that they wanted you to do it, which is to set up something like this, where you have the same kind of thing I was talking about, n-1, because you're starting in year 1, right? So the first press gets you to year 2. But so you divide by this using a calculator, and then you take log of 1.08 to both sides. And I'm laughing because, of course, to do this you have to use a calculator, which means that this entire method relies entirely on doing this, because no one has any idea what that is without a calculator. But in any case, that's the way that they wanted you to do it. And it's just so ridiculous. Like, what? This could have been a really interesting question if this percentage had been, and this number here, had been an interesting number such that you could have evaluated this log by hand, because like you could have used change of base law and something would have cancelled and it would have been quite nice. Like, it's possible to write a question like that, but because both of these papers are calculated, it's just, there's no reason to. You write this in bold at the top here, but then you're just allowed to use, oh sorry, I'm getting off topic, but it's just a complete waste of time. Find the total profit. So actually we get to something interesting here now, and again, it would have been nice maybe if the entire question had been centered around something like this. But it's given you a hint. This is a geometric sequence, right? Because you times by 1.08 every time. So you use the formula from the formula book. Here's the thing here. N is 20 because it wants 20 years of trading. R is 1.08 and A is 20,000. And you just put that in the calculator and you get the answer. Again, sure. Yeah. I mean, if it was non-calc, they could have made the numbers in a way that this actually ends up doing in some intelligent way being doable, but it's not, and it's just a waste of time. But anyway, good. So a vectors question then, moving on to something a bit better. I always write vectors as column. I don't know about you guys, but I just prefer column every time. So A to B is that, and B to C. Make sure you get your directions right as that, which means you can go either A to C or C to A, but they've asked you A to C, so we might as well do A to C is this plus this. So minus 3 plus 1 is minus 2, and so on. Minus 4 plus 1 is minus 3, and yep. And now if we're doing this, the obvious way of doing that is to use cosine rule, because it's asking you about cos. So we could just work out all the lengths of these by doing the magnitudes and then just do cosine rule. So let's just do 1 squared plus 1 squared plus 4 squared square rooted. It's just 3d Pythagoras. This 3, 4, and 5. I haven't even bothered writing in the negatives, because negatives square to positives anyway. So yeah, these are all the magnitudes of all the vectors. And then we can just fill that into cosine rule. I want ABC, which is this one here. So this magnitude, which is this one here, needs to be on its own over there. All the roots obviously just square out, which is why I wrote them as roots. And you end up with this. You can just type that into calculus to get this. Of course, if it was non-calc, you could do something intelligent with these surds, like an actual mathematician would, but sure, we'll just type it in and we'll get this and we'll get this, and we get the answer. Question 7, about circle C. So just move these two things around to put the x's first, then the y second, then we complete the square twice. So halve that number of 5, take away 5 squared every time, halve that number, take away 2 squared. Put those two numbers on the other side, and we get this, and so we have a circle centre 5 minus 2, you change the signs there, and the radius r squared is 18, so root that, you get r is root 18. As a simplified surd, you can just type root 18 into a calculator, and it will just immediately give you 3√2, or you could actually know how surds work, but you don't have to, because, yep, line L has equation this, given L is tangent to C. So tangent to C means it just touches the circle and only has one intersection. Now that means that when you were to go to solve for the intersection of these two things, you only get one answer, which means the discriminant of the quadratic that you'd be solving is 0. So that's all of our logic here. So let's actually go to do that. Let's plug this y into here. And the reason I'm going to put it into there and not there is because then I only have to put in one y term. I only have to put 3x plus k in one time because there's only one y there because it's in completely the squared form. So I'll put this into there. I'll do some expanding out. Obviously this expansion is not trivial. Just be very careful with it. Just write out both brackets and make sure you do your proper multiply every term by every term. Eventually you get this, you tidy up for this. Now this is the quadratic. I've grouped up the x squared term on its own. I've grouped the x terms together, and I've grouped the non-x terms. And now, like I said, the discriminant of this quadratic needs to be 0 for one intersection, for one solution. So b squared minus 4ac is 0. So this thing squared minus 4 times 10 times all of this is 0. And we just kind of evaluate that. We expand everything out again, we tidy everything up, and then we type that into a calculator in the quadratic solvi program, and we get this as our answer. And k is a constant. Oh, sorry, 2 possible values of k in simplified surds. Your calculator just gives you those like this anyway, so those will be your answers there. Okay, so this question is about some population thing. So there's the formula. 1,000 at the start means t is 0. N is 1,000. T is 0 means e to the power 0 is 1, so n just equals a, which means a is 1,000 because n is. And then here, 5 hours, so when t is 5, n is double, so n is 2,000. So we get 2,000 equals 1,000 because we know what a is now. And then t is 5, I've said, so we get this. Divide by 1,000. Take log of both sides. I call this log, by the way, sorry, in case I didn't make that clear. I know lots of people call it ln, but it's just log to me. And then we divide by 5 and we get that. You could also leave it as decimal if you wanted to. Although, oh no, 26, that's the next question, sorry. Hence find the rate of increase. Just read this carefully. The rate of increase in the number of bacteria, that's dn by dt. So we need to find dn by dt. So differentiate this. Of course, differentiate an exponential doesn't do anything, except this k will jump down to here if you have a k in front there. So it'll be a k e to the kt, but I know what k is, right? I had that as a decimal. I know what a is as well, so I just type that into a calculator and get this. And now 8 hours, so we just shove t as 8 into there, and we get this result, which you can leave to 2 significant figures as that. This is a second population, so this is a different growth formula here. And we have, given t hours at the start of bacteria, there's an equal number of bacteria in both. So we have this thing is equal to this thing, and we just need to solve for t. So okay, well, we can just divide by 500 to get this if we want to. I divided here by this one here, and that means I can take away these powers here to get this, and then take log of both sides again, and then divide by this, and we'll end up with t as something around there. If you're going to work in decimals like this, I wrote in decimals just because it was easier than writing down stuff like this every time. But in the calculator, I did actually type in stuff like this because that gave me a more accurate answer at the end. But I just wrote down these to make it easier to write into PowerPoint. But in the calculator, I was holding all of the good values that don't round at all. Good. Question number 9. So just partial fractions here. So this thing equals this thing. And then times this one by, it needs an extra 5x plus 2, and it needs 1 minus 2x. This one just needs a 1 minus 2x, and this one needs 2 of those to get all the denominators to match. So we have this, and then we just compare the numerators to make this. Lots of ways to go from here. I just shoved in x as a half to get rid of this bracket, which gets rid of the a, and this bracket, which gets rid of the b. So I just end up with c times whatever this is when x is a half is equal to whatever this is when x equals a half. Apparently it's that. Solve for c is this. And then if we get rid of these two brackets here, we can use x's minus 2/5 for that, because 5 times minus 2/5 is minus 2, plus 2 is 0. So that goes over all this and all this, and we end up with b times whatever this is when that is, equals whatever this is when that's that. And we get this. And okay, now we can put both those results back into here, and we can evaluate maybe at x equals 0. So I've put in b as 1, c as 2, and evaluated x is 0, which gives me 9, and then 2 here, and then 1 there. And we can get a as 0 pretty quickly, which is good. Okay, so that's all of that bit done. And then this is actually a pretty hard thing to do here, I think, although hopefully you'll have done some practice of it. So we have this as the function, right? Because we found b as 1, c as 2, and a was nothing. So it wants us to binomially expand this function here. So we can't do that with it looking like this. So we make this a minus 2 here, and we make this a minus 1. So it looks like this. And now we have to use the binomial expansion formula when n isn't a positive integer, which is fine because that's in the formula book. And we only need it up to here, right? We only need x squared terms, so we can ignore everything beyond there, just need these 3 bits here. Now this only works when there's a 1 here. So what I can do here is I can factorize out a 2 from this bracket with the power out there. So just factorizing out 2 times these things makes this. And now this is in the form here. I mean, I've just written it the other way around. It's 1 plus 5 over 2x, isn't it? And when you've got a number here, that just copies here. So if this was a 2x, that would be an n brackets 2x, and this will be all of this, and then 2x all squared, right? So I'm just going to use that with a 5 over 2. And likewise over here, although this is already in the right form, with just a minus 2x to use down here, so that's fine. Of course, when you've got a product, 2 times this to the minus 2, just do 2 to the minus 2 times this to the minus 2, 2 to the minus 2 is a quarter. And I think I'm now ready to expand, right? So this is a quarter. This I can follow the formula for, like I was saying, so it's just 1. And then we have n is minus 2, right? So minus 2 there, and then just times x, which is 5 over 2x. And then plus, and then n is minus 2, so it's minus 2 times minus 2 minus 1, all divided by 2. And then x squared is 5 over 2x all squared. So that's that one. 2 to the minus 2 is a quarter. And now this one here, same idea. 2 into 1, and then minus 1 is n, times x is minus 2x. And then plus n is minus 1 over 2, and then minus 2x all squared. And you just expand this out and sort it all out, and eventually you end up, there should be a plus dot 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 there, I just forgot. And you'll eventually get to this. But I think that was probably the most difficult question that we've done so far, and maybe in the whole paper, who knows, I forget what actually comes next. Oh, we also have to find the range of values for which this is valid. So looking at this thing here, this tells you this is only allowed when x, the modulus of x is less than 1. Now here I've used 5 over 2 as my x, so I need 5 over 2x to be modded to be less than 1, which gives me x less than 2/5, just timesing by 2 divided by 5. Over here I've done the same thing, but I've used minus 2x as my x. Now the minus 2 doesn't matter because modulus makes it positive anyway. Divide by 2 and we get this, but this is a more restrictive bound than this, right? Because 2/5 is less than a half. So this, I just need this as my bound, mod x less than 2/5. And good. Question number 10. Actually, this was probably the most difficult thing. You've got a lot of time, I would say, for questions like this. So I did a few things that just weren't working until I eventually just stumbled on the thing that did work. I mean, you've got to think about your double angle formulas here. Double angle formulas aren't in the formula book. You do have this, and you should know from these how to derive the double angle formulas if you're not just going and remembering what they are. So just set a equal to b, and you get sine of 2a equals sine a cos a plus cos a sine a, which is 2 sine a cos a. And likewise, if you do it here, set a equal to b, you get this. And here you can write in a few different ways. If you replace the sine squared with a 1 minus cos squared, cos minus cos is 2 of them, so that's 2 cos squared minus 1. Or if you replace this with a 1 minus sine squared, you can get this here. And essentially what we're going to have to do here is just try all of, so sine 2 theta, there's only one way to rewrite that as this, right? So that's fine, just replace those with this. Cos 2 theta, there's a bunch of different ways to write, here, here, or here. And eventually, you stumble upon if you replace this one with this one and this one with this one, everything goes quite well. Now the hint there is, I guess, that this 1 minus 1 goes away and this 1 minus 1 here goes away, and that's why that was maybe possible to spot without too much trial and error. And the fact that it all cancels is nice, because now we can just factorize out a sine from the top and factorize out a cos from the bottom. Divide everything by 2, I guess, as well. Then do that factorization. Sine over cos is tan, but of course sine plus cos over sine over cos plus sine, those are the same things, right? Just a different order. So that cancels with that, and we just get sine over cos, which is tan, which is the right-hand side. So yeah, don't be afraid if you go down some wrong paths there. Just keep going. Try a bunch of different things, and eventually you should work it out. Now solve this. Of course, we just use this result here. So all of this. Now this isn't quite the same as this, but I think if I just replace theta with 2 theta, if that theta gets replaced with a 2 theta, or a 2x I should really say, then this 2 theta gets replaced with a 4x. So I think this is just tan 2x here. So tan 2x equals this is what I want to solve in this range. Of course, divide both sides by, well, tan is sine over cos, right? And now I can cancel sine 2x here. Now just be careful here. If you divide both sides by sine 2x, that's fine, unless sine 2x is 0. And sine 2x is 0, well, sine of x is 0 at 0, 180, and 360. So sine 2x is 0, or 2x is equal to those things, maybe, which divide by 2 means you get the answers of 0, 90, and 180. The only answer that actually works in this range is 90, because 0 isn't in the range and neither is 180. So, okay, that's means that one answer is 90, and we just need to hold that on the side here while we divide by sine 2x, which we can now do because we've recorded the solution when that happens. Or we've recorded the solution when sine 2x is 0, so now we can safely divide by it and not lose any solutions because we've recorded the one solution that exists. Times by cos 2x, divide by 3, and now of course we can just do a regular old solve to this. We can do a transformation if you want to. I maybe should have done a transformation here, but I was being a bit lazy. So okay, so we're looking between 0 and 360 then, of a z solution here. For this, cos inverse gives you the principal solution. Break out the cos graph. 70.5 is a solution, which means 360 minus 70.5 is a solution, which is that. And then divide by 2, of course, because z equals 2x, so divide by 2 to find x, and we get these two solutions. So 1, 2, and 3 are our 3 solutions. 11 then, so we have this function here, which is quite an interesting function, log of x all squared. Don't make the mistake that you can bring the 2 down to the front here. Log of x squared, you can bring the 2 down, but log of x all squared, you cannot do that. That's not a thing. So here it just says use trapezium rule. Well, actually, trapezium rule is just in your formula book, and y0 and yn refer to the first and last ones, and all these ones are the ones in the middle. And h refers to the gap between the x intervals, so in this case 0.5. So we literally just shove that into the calculator and we get the answer. 3 marks for like, yeah, cool. Use algebraic integration, so this is where the real question begins, to actually find out the region here. So we need to integrate this function between 2 and 4. So how do we integrate this? Well, there's a bunch of ways of doing it. I thought about using parts with log of x times log of x, but then actually what's easier, and also you can use a substitution here, that also totally works, u equals log x, that does work. But actually what's easier is just timesing the function by 1, which is how you would have learned to integrate the original, just log function. So times this by 1 and then do integral by parts. So integrate that for an x a couple of times, so integrate for an x, integrate for an x, and then leave this one alone there and then differentiate it here. So the 2 comes down to make log of x to the power 1, and then you differentiate this, which is just 1 over x, and you put it there. This x cancels with this one. Now to give you this, this looks weird because this bracket starts but doesn't end, so that's a typo on my part. Should have ended, I think, there, that bracket there, because all I've done is I've evaluated this bit at 4 and 2, so that bracket should end there. Then we take away 2 lots of the integral of just log of x, which again, I can integrate by doing parts and using the same trick again, just timesing it by a 1. So now integrate this one for an x and an x, leave that one alone the first time, and then differentiate the second time. I realize lots of people won't integrate by parts like that. They'll set up a little table with du's, dv's and stuff, but I just think integrate the one that you'd like to integrate a couple of times, leave the other one alone and differentiate it the second time, and that's just how I do it in my head. Cool, and now we just need to evaluate well, we've evaluated this already. I've replaced this 4 with a 2 squared because now I can use that aforementioned rule that I was going to mention where the 2 can come down here. This here is still getting done. Integrate that for an x, differentiate that for 1 over x, these cancel, just give you a 1. Integral of 1 is just x. So that's cool. Yeah, this is all just doing regular algebra stuff. Expand out that 2. Be careful with these negatives. Some of them are going to become positives, like this last one here. 4 minus 2 is 2, is where that comes from. This is just 2 log, this is 2 squared, and then that 2 goes there to make 8 log 2, minus 2 log 2 is 6 log 2. Very similar to the question I did here. Now this is 2 squared is 4, times this 4 is then 16. Remember, you have to square first. So we get 16 log 2 squared. Then we get this here is just minus 2 log 2 squared, which makes 14 log 2 all squared. And then minus 12 log 2 squared plus 4 will be our final answer. Good, and so we have the answer in the way they wanted. So that was quite tough as well. I think we've only got a couple of questions left. We've got a quadratic modeling question here. So it says that this distance here is 90. So this point up here we can just call 90 comma y or 90 comma h. It also goes through the point 120, 27. So that's pretty cool. So we've got a quadratic function here, which they've given us. Looks a bit like this, maybe. And we know a couple of points here. There's lots of different ways you can do this. The way that I decided to do it was differentiate this to make that. And I know the x coordinate for which this is 0. Like I know the turning point. Dh by dx equals 0 when x is 90. So I can just shove in 90 there and I get this equation. And now I can also just put in these two numbers, the original thing, to find... by the way, I knew this was a 3 because of this 3 here, because it goes through 0, 3, so that's how I got that straight away. Anyway, then I put in these numbers here to the original equation, I think, and we get this, and then I think I times this by 120, and then did this one take away this one, I think, this equation take away this one, to get this minus this plus nothing equals minus 24, and then just divide by this to get that, and then substitute it into here, I think is what I did to get b as that. And so yeah, we have our equation now. Finds, according to the model, the maximum vertical height. You just put in x is 90 into here to get h, and you get h is this. The horizontal distance from when it was first hit to when it hits the ground, so I want this root here. So we just shove that into a calculator and find the two roots. The calculator says this. Of course, this refers to the value you'd get back here if this quadratic continued. So we're looking for this one here. It's 185 to the nearest meter. And two possible effects, limitations. Another effect would be the fact that you've modeled it as a particle and it's not a particle. It could be spinning. There's lots of things you can say. You'll all have your standard responses to that, I'm sure. Question number 13 is quite interesting. It's about parametric equations. Show this thing here. There's a few ways of doing this. It's only worth 3 marks, which is interesting. I just took away 3 from both sides here and then collected that together, I think. Times this by t squared plus 1 over t squared plus 1, so that I can put these together. And, you know, t squared minus 3t squared is minus 2t squared. 5 minus 1 is 4. 5 minus 3, of course, is 2. Yeah, good. So we get this. And then y squared, just square top and bottom here. Oh, no, sorry. Then I squared this because I need to square it as well. Y squared, just square top and bottom here. And then we can just put these two things together and hope that they equal 4. That was my plan. So, okay, well, we can just square top and bottom of a fraction separately. The denominator is the same already, so that matches well. Expand all this out to get this, plus this one over here. And then all of that, I think, works out quite nicely to this. Now, how does that just equal 4? Well, if you factorize out a 4 from the top here, you get this. And then, not the easiest spot, but notice how this actually factorizes to be t squared plus 1 all squared. Because, just expand that out if you want to. But you definitely get this. Cancel these two things, you get 4. Good. Question number 14 is actually just a great question. You can do this, so you just need to find dy by dx. You can do this by using quotient rule. You could of course do it using product rule if you did this to the power minus 1. But the absolute easiest way of doing this is to just spot, and by the way, if you were doing that, you just use the mark scheme to check through your working, because it's all there. But the absolute easiest way to do this is just to spot that this is actually a difference of two squares, because it's almost like x squared minus 4, isn't it? But it isn't, it's just x minus 4. So instead of using x plus 2, x minus 2, just use root x minus 2, root x plus 2. Because then this multiplies out to x, the middle terms cancel, and this makes a minus 4. And of course now this here cancels with this here because it's just written the other way around, so we get this. And now differentiating this is trivial, right? And so we're going to get to the answer very quickly, and we'll end up with a as a half. Or sorry, a is 2, isn't it? Because it's a half there. So a is 2. Yeah, just a really, really interesting question. Anyway, last question here, I think. Use proof by extortion to show this for anything less than or equal to 4. So okay, we just use n. Natural numbers starts at 1. So just use n as 1 first. I haven't actually checked whether Edexcel agrees with me on that, but I think it does. If it doesn't, just go with 0 first. Oh no, in fact it must be agreeing with me because 0 gets 1 cubed greater than 1. So that's not true. So yeah, Edexcel must be agreeing with me that natural numbers start at 1, so that's good. So yeah, put in 1, you get this, which is bigger than this, which is this. So we have that this one is bigger than this one when n is 1. N is 2, you just do the same thing, you get this. N is 3, you do it again, you get this. Just set it out nice and neatly, you get 2 marks, and we're good. Given this is odd, use proof by contradiction to show m is even. So contradiction means we need to assume n is odd, and if m is odd, we can write it as this, 2n plus 1, for example. And then we put that into there, and we expand out. You can use some binomial if you want to do that. You tidy up, you factorize out of 2, and the fact that you can factorize out 2 means that this is definitely even. So what we've said here is if m is odd, then this expression is even, which is not true because it's told us that this expression is odd, which means m must be even. And we have our entire paper done. And that is excellent. So thank you for watching.